Thanks, everybody, for showing up to this brown bag. We've got Stardust with us. She's going to be talking about all kinds of fun stuff, and I'll just let her go ahead and talk about that and give a quick introduction. There's a questions thread on the brown bag channel in Slack, so go ahead and post your questions there, and I'll ask them after we wrap up. So take it away, Stardust.
All right, cool. So yeah, I'm Stardust. I have been a software engineer for about 10 years, I guess. But I've done a bunch of teaching for Dev Bootcamp and some other Hackbright and various coding schools. And yeah, so I'm excited to talk to you guys a little bit. We're going to be doing test-driven development in Jasmine. I guess I can. Yeah, I don't know. I'm not sure if I should give more intro than that, but I think I'll jump in since we're a little bit short on time. So I will go ahead and start sharing my screen. This is my first time giving a lecture over Zoom, so it's there. If I have a couple of little technical challenges, forgive me. Cool. So I think Beej posted a link to to my GitHub repo that I wrote up for this. So basically, sorry, I'm trying to figure out how to move the okay, cool. Yeah, so I hear that maybe some of you have talked a little bit about test-driven development, but maybe not all of you. So I'm going to just give a quick overview of what it means. Test-driven development, basically you start with the requirements for the project. You actually write tests before you have any code down. Then you write your function and sort of iterate on that. A lot of times people will describe this process as red-green refactor, red being when your tests are failing. So you write a test knowing that it's going to fail. And usually most testing frameworks will have that come up as red. And then you write code to actually pass the tests. There's the green part. And then refactor, you actually make your code performant. So actually not just barely passing the tests, but actually doing what you want more smoothly. So sometimes people will use test-driven development when they already know very clearly what the requirements are. When there's especially super tricky logic that has lots of edge cases, it's really good to use test-driven development because testing out all of the intricate cases manually is going to be really annoying. If you make a change, making sure that there's no issues with stuff that you've already tested is going to be really annoying to do completely manually. And yeah, if you find yourself repeatedly doing something you've written your code and you're like, okay, now I have to create a sample one of these and then do this and then do that. It's often good to actually do tests up front in that case so that you're not sort of going through those motions and wasting time. There's sometimes when it doesn't work as well, especially if you're sort of doing a more open-ended project where you're not exactly sure how you want it to behave up front. If you're sort of not really sure how a user is going to interact with it, maybe you have a client that asks for something and you're like, I'm not entirely sure what you're talking about. Ideally, you want to get more information from your client and figure that out. But it's also pretty rare to use it when you're just prototyping and just trying to get something out to get some feedback. But you don't expect that to be your final version. There are some times when the testing is actually just writing the tests. The upfront cost of that is just more than doing the tests manually. But there are a lot of cases where it is super useful. So we're going to go ahead and jump in. So I'm using Jasmine. If you're following along on your own computer, There's some setup instructions at the top of the README. Basically, you're just going to need to run npm install and get it going. Sorry, the whole talking into a void and not getting any feedback is a little nerve-wracking sometimes. So I'll just try to calm down and not let that get to me too much. Cool. So Jasmine is a framework in Node. I think you guys have used at least some JavaScript. I'm not sure if you've done Node in particular. But the basic building blocks of it are describe blocks, which are sort of a scoping mechanism. So you'll have like a bunch of tests inside a describe block, and then it is sort of your spec for a specific kind of like testing one specific aspect of something. And then expect is the actual test. So you'll say that you expect something to be something else or to equal something else. And that part is called a matcher. So to be and to equal are sort of the most common matchers. There's a bunch more, and you can take a look at this link and kind of get a better idea of what all of the possibilities are. And we'll use a couple of different ones as we go through. Cool. So one thing that you could do is sort of set up your configuration file to have certain, so there's a couple of different options, like whether you want to stop whenever you hit a failure. So either within a single spec or within the whole describe. If you hit anything that fails, you can say stop, and that's fail fast. So right now we're going to say just run all of the tests, but sometimes you may want to say if a whole bunch of things are failing, you may not want to see all of that output. So let's go ahead and look at this code that I prepared ahead of time. So again, I don't know all of your backgrounds super in depth, so I'm not sure how much you've worked with trees. So I'm going to do a little bit of an overview of how trees are implemented. So usually when you're working with trees, you'll have some kind of tree node. There'll be some kind of value, and then a left child and a right child. So it's going to be pretty similar to a linked list, but instead of just having a next node, you'll have both a left child and a right child. And I've got a couple of sample trees sort of laid out here. So you'll have your root node, that'll have a left child and maybe a right child. So hopefully that can give you a sense of, hopefully everybody's at least seen trees a little bit. If not, maybe I'll get some questions about that at the end. Cool. So this is a basic simple tree node, and then I have a function that's doing a deep equality check, and I've written some tests for that. So let's look a little bit at those tests. So basically, this guy, hopefully you've seen constructors in JavaScript. This is just saying, given a certain value and maybe a left and right node, or maybe just null. So these are default arguments. Just set the class variables for that. So if we just pass in 3, that should set the value to 3, and left and right should be null because we didn't pass anything else in. So we just literally say we expect the value to be 3, to equal 3. We expect the left to be null and the right to be null. And then we've got a couple of other tests here that are saying if we have one tree node, with value 6 and another tree node with value 6, our dot equals should return true. And here we have some with different values. And here's a few that have more interesting structure. And here's the same structure, but with a different leaf node. So we call any node that doesn't have any children. So the left and right are both null. We call that a leaf node. We've got a couple here that are sort of more complicated. So I'm going to go ahead and run these tests. Right, I can't tell whether the video covers the things on your screen or just my screen. So cool. So I'm going to go ahead and say
all the Zoom components, like the Zoom windows, they just cover your screen.
Okay, so cool. Cool. So you can just run all of the tests in your suite just using the Jasmine command. If you want to run just a specific file, you can say Jasmine. Usually you put it in a directory called spec. It's going to be the same output right now because I only have the one spec file, but sometimes it can be nice to run just a specific test if you have like sort of a larger project with lots of different components versus running just all of the tests. Cool. So this part I've sort of already done. I already developed the equals function. So what we're going to do now is go into talking about another function, creating from array. Oops. Oh, I see that. I pasted that in from above. Cool. Okay, so the create from array function, we want to take an array of values and make the tree that's created from taking each of those values and filling an entire level with them. So see, the 5 is its own level, and then you have the 2 and the 7 taking the next level, and then the next level has all of these guys. So we want to write a function that takes this array and gives a tree with this structure. Right now we don't even have this function. So, but we're still gonna write a test. I'll talk about the before each in a minute. But for now, we'll just have a okay. So all of these components, they're just functions that take a string that describes what the test is doing, and then a function. Okay. The screen is so small, but looks better like that. So we're going to say that we expect that if we call our tree node dot create from array function with an array containing just a single element, that will get a new tree node. This should be the same as the tree node. Cool. So right now, if we run this test, we're going to expect it to fail. We didn't even write this function, so obviously it's not going to pass. But it can be interesting to take a look. So this text, tree node, tree functions, create from array. So I didn't do a great job of naming here. But what it does is it takes the outermost describe and then the describe that you're in, as far, like it nests down and down and down, and then throws the text from the it. So when you're naming these, excuse me, you want to consider what the output's going to look like. You want it to read as sort of a sentence. So at least the create from array can create a single element tree part makes a reasonable sentence. The tree functions in there is a little spurious, but cool. So it's according to our test-driven development philosophy, this is good. We've done the red part. We've got our failure, and our failure is that this create from array is not a function. So to get to green, we need to go back and actually create that array. And we expect this to be an array. Cool. So that should get us past that particular failure. Let's see. What did I do? There is not a function. Then let's save it. Okay. Now I have to live debug because I expected that to work. Cool. So tree node. Right. I called it as a static function, and I wrote it as a class function. Cool. So now we're not getting the is not a function. We're able to call it, but we're getting undefined. So when we call this, we're expecting the result of this guy to equal this new tree node, but instead we're getting undefined. So let's see why we're getting undefined. Looks like we should be returning something. Let's just return true. Okay. So let's see, what did I do wrong? This is where I normally ask for input, but what I did wrong is that. I forgot to say new. Cool. So technically I've gotten to green, but you might notice this isn't actually solving the problem that I'm trying to solve. I just said create a tree node out of the tree, out of the first element of the array. So if we have a multiple element array, it's not going to do anything. So now we want to actually test that we're doing something a little bit more interesting. So wait, here we want 3, 5, and now I'm going to make use of this before each that I defined earlier. So before each is a function that's going to run before each of the tests in this describe block. So it's going to create this dot root. So instead of manually making this all over again, I'm just going to say that I expect when I create from array, the array 3, 5, that I expect it to be the same as this tree that I created up here. So we expect this not to work because we didn't actually implement that. Yeah, so here it's saying the left child was null. We expected it to be a tree node with 5. So let's go into actually doing that. So I'm trying to keep an eye to the time and figure out how long I want to spend on this one. So I think we will. Sorry, when are we going to switch to questions and answers?
You can just keep on going. I don't know, like 15 minutes or something like that.
15 more minutes. Okay, cool.
That sounds good.
All right, so I think I'm going to sort of jump ahead and just copy over what I had defined earlier for this guy, so that I can move ahead with testing some other guys. So basically here we're just saying, if we're at the end of the array, we're going to return null. So it's going to be just an empty node. And then otherwise, we're going to create a tree node from the thing at our current index, which by default will be 0. And this is probably the most confusing part of this function, but the idea is that your child, given that you're traversing this array, and like the next like whatever level you're on, twice that is going to be taking up the next level. So if you're on level 2, then your left child is going to be double that, and then +1, and your right child is going to be +2. So I'm not going to try to walk through the logic of that too much right now, but I'll just sort of show that works and move on to the next method. And I'll commit all of this code so that you can play with it on your own afterward. Cool. So depth is the next guy that we want to look at. So here, sometimes Sublime is helpful and sometimes it is anti-helpful. Cool. So basically we want to say if we're checking just a leaf node, the depth of that should be 1. The depth is basically how the longest path from the root to a leaf node in your tree. So we want to say that we expect tree node. Sorry, this one is a instance function, not a class function, so we want to do it on the stock root depth. One. So again, we run it. It's not a function, so we're going to want to define it. Doesn't need any arguments. Cool. So we move from it's not a function to we expected it to be 1. So this one's pretty simple, so I think I'll just go ahead and implement it. So basically, since we're working with trees, everything is going to be fairly recursive. because it's a recursively defined data structure. So I think we're going to want a helper function here. Node. So if the node that we get is null, then we just want to return 0 because we've come to the end. Otherwise, we want to return the max of the depth of the right node and the left node. And then +1 for ourselves. So the sort of interesting thing I wanted to do here is instead of doing a before each, I'm doing a before all here. So this is going to happen once at the beginning. And then we're going to say, okay, here we'll take this dot root and add a left true node. We'll give that same value. And now we expect the depth of this to be 2. And here, if we can go ahead and add some other value. Trying to not reuse things. So here we have this dot root, and that's actually getting modified each time, and we're sort of building on it. Whereas here we have the before each, and that just happens once. And if we were to change, to say if here we said this dot root dot, oh, sorry. So we expect if we add that, I should have copied it before I did that. Oh, well. Cool. So, so here we changed this dot root. We added something to the right of it. But here, even though this test is happening later, we don't have that element anymore because the before each is sort of redefining that each time. Versus down here, we have the before all. And that happens once, and then you can actually modify the state. So it can be a little bit dangerous to do this state modification, especially if you were to change your order from being not random, so in order, to being random. If you do that, oh, did I just get lucky? Yeah. So if somebody is like, oh, I want to run the tests in a random order, and they don't realize that you have state that's actually growing and changing, they might end up with failures that they don't understand. It's usually considered best practice not to have state that you're updating through your tests, but to like fully set it up in each test. So like the way that we're doing in this guy is sort of the best practice versus doing it this way. I mostly just did this to give that example. Cool. So I will talk a little bit about, I'm going to turn it back to false and leave it there. But I'm going to make a note that this is so we'll talk a little bit about whether a tree is balanced. So I've got a couple of example trees. Where did my example trees go? Oh, yeah. So this guy, even though it's not fully filled, counts as balanced. But if we added another layer here, basically the idea is if you have more than, if you have a difference of more than one in the depth between any, yeah, so the depth between the depth of this leaf node versus the depth of this leaf node is off by more than one. So we say that it's not balanced. So leave this one alone. My naming conventions are not the most amazing in this lecture. I apologize for that. So we want this to also have a root dot right dot left. Yeah, I guess I had one here. So just write one quick test for I wanted that to be a particular tree node, didn't I? All left. And let's do one true. Create from yeah, so now we're getting the, it's not a function. So we need to go back up to balance. I think I'm about running out of time. So I'm just going to say return true, and this is obviously going to look for one of them. Oh, wait for a, ah, great. Cool. All right, so I'll sort of leave getting that to actually work as sort of an exercise to the reader, and I'll commit this yeah, hopefully that helped you a little bit understanding the approach to test-driven development, as well as um, maybe you learned something about trees. So I guess I'll open it up for questions.
All righty. Thanks so much, Stardust. Let's see here. So Jubilee says to answer some questions. I've seen similar tests before in Jest, but I'm not terribly familiar with tree structures. So a little bit of feedback there.
Mm-hmm.
Then a whole pile of anonymous questions. Let's see here.
Mm-hmm.
And if you have anonymous questions or non-anonymous questions, I posted a Slido link to the channel, so go ahead and put them there. One question is, there are a lot of, oh dear, it scrolled just as I was reading it. Let's see, where did it go? Oh, somebody voted for one, so that's going to go first now.
Cool.
What do you like about Jasmine compared to Jest or Mocha and Chai?
Yeah, honestly, I have mostly used Jasmine. I've used just a little bit, so I don't have like super strong reasons for preferring one over the other. I like the simplicity of Jasmine, but I think Jest actually has fairly similar syntax, so I'm not. I wouldn't say that I have a very nuanced answer for that.
And I guess maybe to put you even more on the spot with a follow-up question, there are a lot of TDD frameworks out there. How do you choose which one to use?
Yeah, so that definitely does require a fair bit of, I think, actually, one of the reasons I like Jasmine is that I like the style of their documentation. For whatever reason, it like this link that this just like really works for me personally to like understand what it's doing. I think there are probably some trade-offs in terms of like I think Jasmine is a nice like sort of easy to get up and running. It may not be as expressive as some of the others, so it sort of depends on like what your application is and what kinds of things you need to test. Yeah, so I think when I'm deciding on a testing framework, I sort of think about what kinds of things am I going to need to test? Am I going to need to test like browser integration? Like, am I going to need to do sort of like end-to-end testing? Am I going to need to just do sort of like business logic testing? I think Jasmine is pretty good for business logic. I haven't used Jasmine for end-to-end testing. I don't know if it how good it is at that. I'm mostly a Ruby person, so I mostly use RSpec. So yeah, my ignorance on the JavaScript side is showing, but I decided to use JavaScript because I heard that you guys had slightly more, that you had more familiarity with JavaScript than Ruby, so it seemed like a better one to jump into.
Cool. All right. Do you have a story of how testing saved the day?
I feel like when you, I more have like failure stories of when I should have done testing that I didn't. I feel like when you do it right, there aren't like dramatic stories. So I've definitely had cases where I've found that like, yeah, I just like put in a lot of manual effort to test things over and over again. And like once I finally wrote tests, it was like, oh, yep, that I definitely should have like been writing tests from the beginning. When I've actually done TDD, I think it has probably saved me from things I just don't know what they are because it didn't happen.
A related question: when would you not use TDD?
Yeah, so I think I gave an example in my README here, but one thing is like I think that like there are testing frameworks that do this, but things like testing the behavior of a web page after you've made an AJAX call, so like making sure the elements are all in the right place, like you can do that, but a lot of times it's sort of like visual, like you want to make sure that the elements are like visually in the right places, and doing that with a testing framework can be a lot of setup. So if you're only making like 1 or 2 Ajax calls in your project, it may not be worth setting up the like the whole framework to get just those couple of tests written. So yeah, I think it's more when you're going to be exercising the code a lot. If it's going to be used by a lot of people, it's really good. If it's just sort of like a side project that you're going to do once and then throw away, maybe it's not as important.
Oh, all right. When would you, and I guess when and why would you run tests in random order?
Yeah, so I think the reason that that's an option is to sort of make sure that your tests are more atomic, so that you have the ability to, you want each test to sort of be standalone, and not depend on other things, because you want it to be very easy to look at your tests and understand what's happening. And if you have like built-in assumptions that like this test runs and like does something with some data, and then this other test runs it, and then that test fails, it's not going to be super obvious to someone who's like coming into your code base for the first time that like the reason it's failing is because something got changed earlier on, and like they'll have a longer trail to follow basically. So I think the main reason that you would run it as random is to make sure that you aren't having any side effects in your tests.
Cool. How much time is typically spent writing tests versus implementing the thing you're trying to test?
Ideally, you want the time spent writing tests to be fairly minimal. When you're there's usually like a little bit of setup. Like you notice I kept some of my like trees rather than writing them out, because that was going to be kind of long in the lecture. So I think stuff like that where you're like setting up the data is kind of the longest part of writing tests, where you're like, okay, I need actual like concrete instantiations of this thing to test. But like probably you're going to have to do that while you wrote the code anyway, because you're going to have some instantiations of your data structure to use to make sure that things are working anyway. So it's just sort of putting that up front instead of after you've written the code. And it codifies it for later, so that people coming in to your code base have that already set up and don't have to do it themselves.
All right. Let's see here. It seems that TDD is really hard to learn in a non-corporate setting. Besides being part of a large team, how can we better practice TDD? I'm going to lump that in with the next question, which is, do you use TDD in all your projects?
Yeah, I definitely don't. So I use it when I use it more often when I'm doing projects with other people than when I'm doing projects by myself, which like I think we all fall into sort of worst practices when we know nobody's going to look at it, look at the code at least. So I think I do try to write good tests. I don't necessarily do test-driven development for my own side projects, but I do try to, at least like when I notice that I have a bug, write a test for it rather than just fixing it and having that sort of like information fall away. Capturing that can help you make sure that you don't have regressions later.
And in terms of practicing on your own, if you're not part of a large team?
Yeah, I agree that that's hard. I think social support is always quite helpful. But yeah, I think probably just doing some like simple, like smaller projects that use it versus trying to jump straight into like a big, super complex thing. So yeah, I chose this example of like doing stuff with trees, partly because it was fairly self-contained, didn't involve a lot of input output. It's like some of those things like capturing stuff from standard in or capturing errors and things like that can be a little bit annoying with testing. It's probably good to get some practice doing those, but I sort of stuck with a more like pure algorithmic thing for this, because then you can just sort of get the basic idea of what you're doing. So I think I would do it for things like if you're doing sort of like hacker rank style things, like interview prep style problems. That's a good place to start using TDD, because like you're going to need to make sure that those are working the way that they're expecting anyway. To be fair, if you're doing it literally on HackerRank, they've written the tests for you, but you don't get to see them. But yeah, I think I agree that it is more difficult when you're doing it by yourself. So find someone to practice with.
Question about binary trees. Does a perfectly balanced binary tree need to be full? That's a question from Tony.
So it depends on what perfectly is doing in that sentence. If you're just, so there are different definitions of what it means to be balanced, but for the most part, balanced just means there's no discrepancy larger than one level off. Yeah, there is also the idea of a full tree, which is like what we're doing with the create from array. Like those trees are like filled as much as possible, but you don't have to have that. So like this guy here counts as balanced even though it's not full, right? So if it were to be full, then the 543 would be a left child of 5. So yeah, there are different definitions, but the most common definition of balanced would say that this is a balanced tree.
All right, we've got time for one more question, and we have one more question, so let's do that.
Great.
It says, the next question is, a common issue I've seen in database testing, and I've seen is database testing and its unique complications. Do you have any recommendations for somewhere to start with DB testing?
Yeah, so again, I'm more of a review person, and I mostly use Active Record, and I really enjoy Active Record, and you can write really good tests for it. I don't have as much experience writing database tests for JavaScript, but yeah, basically, yeah, it's database testing is one of the things that is sort of more like you don't have a lot of input output, so it kind of has that more like concrete, like it's just logic that you're testing. So I think that makes it a like pretty ideal candidate for doing test-driven development. But yeah, getting things set up such that you're like connecting to the database properly and all of that can be a bit of a pain when you're getting things set up.
All right. Well, with 1 minute left, let's go ahead and wrap this thing up.
All right.
Thanks so much for presenting all that information to us.
Yeah.
Kai says, thanks for showing us everything.
Yeah.
I'm sure
right. Let me commit that those changes that I made during the presentation, just so people have that available if they want to look at it.
Oh, perfect. All right. And thank you, everyone, for showing up. And thanks for all the questions. Big Tony says, thank you. Jubilee says, thank you. All right. Thanks for sharing your lunch with us. And it looks like everything's pushed.
Getting there. There it is.
All right. All righty, gang. Thanks again, Stardust.
Yeah. Thank you, guys.
Catch you all around.